Hey everybody, hope you're doing well. Just a quick little tutorial here on how to use your TI Inspire to generate an equation for a linear regression, as well as construct a scatter plot. And then I'll also give you a little guidance on correlation and how we interpret that. So here's a question that you could see in Delta Math, but we use this as our example. So if you want to read through here, if you want to pause the video and read through there, that's perfectly fine. But essentially, here's the year since 2012, be our X values, and then these are the new cases, the crime cases reported in a county in the state of New York. All right, so what I'm going to do is go to a new document and list in spreadsheet again. And the difference here is with X and Y values, I'm going to create two columns and I'm going to use X and Y. If you remember the other day when we were just putting in data, it was just one variable data. We could just call it data and we could work from there. But in this case, now I'm back to talking X and Y. So I want to make sure I label appropriately. And I'll go ahead and get this entered into to my calculator and make sure we've got everything in there accurately. And so what it wants to know, it says write the linear regression equation that represents this data. So essentially they just want to know what is the equation of the line of best fit for this set of data. And then it says using that equation, estimate the calendar year in which the number of cases would reach 1,329. So then I'm going to use that equation to determine what year it would predict 1,329 cases to occur. All right, so you'll notice down here it has a place for you to enter your equation, and in here a place for your final answer. One thing to keep in mind is the rounding. This says nearest hundredth, so we'll keep that in mind as we go through as well. So we've got our information in. Once again, you want to have a blue cell highlighted here. I'm going to go menu, statistics, stat calculation. So, and you'll notice here's one variable statistics, but the difference today is that we're not doing a stat calculation. We want to choose linear regression. All right, so I'm going to go linear regression, mx plus b, and I'm going to call this x, and my y values, I had called them y. And just one thing to notice here, save regression equation, it says as F1. We don't have to change anything with that, just be aware of it, and we'll talk about that here in a moment. So I'm going to click OK. And if you'll notice, it's going to produce for me something similar but different outputs than what we had the other day. So you'll notice here's mx plus b. M is the slope. That's going to be the slope of the line. B is the y-intercept. So there's my slope. There's my y-intercept. So if I wanted to come over here and set up my equation, I already know it's y equals, this would be 25.8. And if I click on this, notice down here there's no other values that go along with it. So 25.8x plus, and if I click on this, uh, whoops, got the wrong button there. Let me undo this. There we go. Here's my 1170.8, and there's my equation. All right, that's everything that I needed. Let's go through how you could do this using Delta Math. So kind of like the other day, copy these values. It'll copy both columns. And then if you do open statistics calculator, all you have to do is click paste values. There they are. Come up here, choose calc menu. And then instead of one variable stats, we're going to do a linear regression. Notice it says AX plus B, that's okay. And then go ahead and click calculate. And notice their slope, AX or MX, 25.8 matches our 25.8. Their 1170.8 matches our 1170.8. So there you could, if you don't have your TI Inspire, could generate that equation. All right. Now, the next piece of this has to do with this little solving component. Okay, so take a look at this right here. It says using the equation, estimate the calendar year in which the number of new cases would reach 1329. So if you do not have your TI Inspire with you, you might have to do that by hand. And essentially, you would be taking 1329 and setting that equal to your 25, hopefully I won't run out of room, 25.8x plus the 117, and I ran out of space there, the 1170.8, and you'd have to solve that for x, okay? Um, if you do have your calculator, so you could add or subtract the 1170.8 and then divide by the 25.8. If you do have your calculator, here's that little piece that I told you about earlier. If I go to a graph, so if I hit Control Doc, add a graph, notice it brings it up as F2, and that's because F1 was already storing that equation, which is kind of nice. So if I just go up there and I hit enter, I don't see it, but it's on there. And I can hit tab, and what I want to know is when is that going to be equal to, like it told us up here, this 1329. So if I just type in 1329 and hit enter, now I've got everything that I need. If you recall, when you don't see the graphs, one of the things you might want to do is go Windows Zoom. I always like to do a zoom fit first, and sometimes, like in this case, it happens to bring that into the window. If it doesn't, you can always then go zoom in or out a little bit until you can see that intersection. So what I'm looking for is that intersection, because now I could go menu, analyze graph, intersection, and just use the resources that we had from earlier in the year to be able to solve this. So if you notice, 6 years after our initial year up here, which our initial year was in 2012, so this would be like 2018, sometime after 2018, but not before we get to 2019. So then what I'd be able to do is come down here and say that in the year 2018, that is when we would reach that 1,329 cases. All right. I'm going to go ahead and click submit. And there we go. Everything looks pretty good. Okay. I also had told you that I would show you how to create a scatter plot. All right. So what I'm going to do here is just kind of undo some of these things. And let's just get back to where we were. And let's say this was our set of data. We've got it already entered in. I already know because I did the linear regression without the scatter plot. But the scatter plot can be useful, and I'll kind of talk you through why there's some usefulness there. I can go Control Doc, and in this case, what I want to click on is Add Data and Statistics. I'm going to bring up something that looks kind of like this, and your points might be in different locations, and that's okay. But I want to just label this as my x-axis. Ooh, and then I'll click over here, and I want to label this as my y-axis. And this is going to give you an idea of a scatter plot, kind of what this looks like. From here, you can also find the linear regression by going Menu, Analyze, Regression, and then you could say Show Linear. And then you'll notice there's that same equation. If we scroll down a little bit over here, notice that 25.8, 1,170.8. There we go. All right. And then you'll notice this is what I tried on the other page to write out for you, and it wasn't really clear because I ran out of space, but this is what I was setting up because we were trying to figure out an output. All right, this was the output. The questions could also, tell you, hey, it's an input, find the output. So you just have to be careful there as you read through those questions that you understand what it's asking. But here's how to create a scatter plot on the eMath video. He'll ask you to create a scatter plot, so that'll kind of take you through there. Just enter your information into your two columns, label it as X and Y. Once you've got it in there, then you can go through that process that we just went through. All right, now looking at this scatter plot, a couple things that the scatter plot could be useful for. One is just to see, what's going on here. Um, is is the rate with this application problem that we're looking at, is the number of cases, as time goes on, is the number of cases going up? And it looks like in this case that it's trending in this direction. It looks like it's trending up. So one of the things that a scatter plot is good for is to determine trends. So let's take a look at maybe a sample problem here where it says determine the type of correlation. So really it's, hey, what is the trend of this data? So as you look at this, it gives you some options down here. And let's just talk about what kind of a trend it shows or a correlation that it shows. Is this a perfect positive correlation, meaning are all of these virtually on the exact same line? Or do they all fall essentially on a line? And you can see that they're not all in a perfect line. So I would kind of steer away from perfect positive correlation. Positive, I feel like is correct because as I move to the right, notice how these data values are trending up. So I would say that's a positive trend. You can think of it as slope being a positive slope. So it's either going to be strong or a weak positive correlation. There's not a whole lot of spread. It's all pretty closely grouped there to what I would visualize as a line going through. So I'm going to go with a strong positive correlation. Let's see how I did. All right, now let's just take a look at another problem here. And let's talk about this. Now, as I move to the right, it looks like this data is trending downward, which would maybe have a negative slope. So positives are out. It looks like there's a negative correlation, so I wouldn't say no correlation. And in this case, maybe a weak negative correlation because it's maybe not as closely grouped to that line is what I'd like to see. All right, so scatter plots help us just identify correlation. All right, I'm going to go back to this page right here, and let's take a look at what else this linear regression gives us. So here's our mx plus b, there's our slope, there's our y-intercept, and you'll also notice this value of r, this 0.9. Okay, this tells us the strength. How strong is this relationship between these variables? So in this case, 0.9, 0.9277722. This is a pretty strong relationship. Let's just kind of talk a little bit about how we determine strength of relationship. It says, which of these following regressions represents the strongest negative linear relationship? Well, here's how regression works and the correlation works. It's going to be a value that falls between -1 and +1. Okay, so as I look through here, this cannot be possible because look at this R value. That is outside of -1 to +1. It has to fall in there. The other three are possibilities. So then what this said right up here was it said the strongest negative linear relationship. So the strongest negative linear relationship, well, this is a positive R value, so that one's out. And we know this one's out because that doesn't fall in our range of values. So the strongest negative linear relationship, which of these is closest to -1? Is it this value or is it this value right here? And as you think about that, hopefully we would decide that this -0.7852 is closer to -1. So that's what I'm going to choose, regression 4. Submit my answer. And I'm going to clear this out. And we were good. We were correct. All right, let's just take a look at one more of those quick while we got you here. Which of the following represents the strongest positive linear relationship? Okay, so the strongest positive linear relationship, when I think about this, I could rule out this guy because that's negative. This is greater than 1, so that can't be it. So my strongest positive would be regression 3. And I'll submit that. Yes, and if you take a look, there we go. One more, just in general, this just says the strongest linear relationship. So just be aware of that. It's neither positive nor negative.